Look at this unlined earth canal. In the Middle East, water infrastructure faces constant threats from severe soil erosion and massive seepage losses. Traditionally, repairing channels like this requires cast-in-place concrete, but that method demands heavy logistical transport, relies entirely on wet trade construction, and requires long curing times that keep infrastructure offline. This is MASTER GCCM, a pre-manufactured geosynthetic cementitious composite mat. This structural diagram outlines the system's 3 layers. The top fibrous surface pulls water in. Beneath that, a 3-dimensional fiber matrix rigidly suspends fine-grained dry concrete. Finally, the bottom layer is a high-density polyethylene membrane, ensuring waterproof impermeability. Up close, you can see this is a highly engineered structural matrix, locking dry concrete powder in place, rather than a thin or loose fabric. By combining the lining and the barrier into a single roll, this system allows crews to install up to 200 square meters per hour. We are going to walk through the exact steps to achieve a continuous, fully functional canal lining in just 24 hours. Step 1 is site preparation. In this prepared trench, the subgrade must be entirely cleared of vegetation and debris, then shaped and compacted. Because the flexible mat will conform exactly to the ground beneath it, achieving a stable, uniform profile is critical for the final structural integrity of the installation. Step 2 is deployment. Here, an excavator uses a spreader bar to carefully unroll the heavy GCCM material vertically down the canal bank. For wider canal spans, the machinery deploys the roll horizontally along the bed to ensure continuous, even coverage. During deployment, crews must handle the mat as a thick, dry, woven material. They verify that the correct textile face is oriented upward, with the HDPE backing laid flat against the soil. While machinery handles the bulk weight, workers on the ground perform manual adjustments to guarantee precise alignment on the prepared subgrade. This disciplined preparation and exact positioning establish the physical foundation needed for the rest of the installation. Step 3 is overlapping the seams. To form a single continuous surface, every adjacent sheet must be layered over the next. This schematic shows a critical engineering requirement. The overlaps must be shingled in the direction of the water flow. This forces the current to pass cleanly over the joint, preventing water from catching the edge and lifting the material. Step 4 is sealing. Here, a technician applies a thick, continuous bead of industrial sealant directly between the overlapping layers. Step 5 secures the system to the ground. A worker drives mechanical steel pegs directly through the overlapped material and deep into the subgrade. Applies secondary mechanical fastening. A technician uses a power drill to drive screws through the sealed seam, clamping them tightly together. Step 7 is hydration. This worker applies a systematic, even spray of water across the installed mat, darkening the fabric and activating the cementitious matrix. The water pressure must remain controlled. High-pressure washing is avoided because it can displace the dry cement powder before it has time to bind. Step 8 is curing. The material transitions from a wet, pliable fabric into a rigid shell. This initial set takes just 1 to 2 hours. The system continues to harden, reaching maximum strength and full functional readiness within roughly 24 hours. Step 9 is the finished outcome. We are left with a durable, fully operational canal, now safely channeling water through the arid environment. By replacing the complex logistics of traditional concrete with a pre-manufactured roll, crews achieve a seamlessly protected infrastructure system in a fraction of the time. This side-by-side comparison proves the immediate transformation. Once installed, the system delivers a service life exceeding 50 years, provides high abrasion resistance, and eliminates seepage through its integrated HDPE backing. The roll-deployed workflow adapts easily to complex geometries. Here, workers install the lining directly inside the constraint space of a concrete box culvert. It also scales up efficiently. In this image, vast panels of MASTER GCCM have been deployed to secure a large area water reservoir. For existing degraded concrete infrastructure, the material acts as an overlay. It can be installed directly over damaged surfaces, bypassing the need for expensive and disruptive demolition. From small channels to large containment basins, MASTER GCCM provides an engineered, rapid deployment barrier, protecting critical water resources in the most demanding regional conditions.